Inshallah, today we have very important issue, which is giving you a link between any two variable, and these two variable could be ordinal or rational. Otherwise, if it is nominal, you cannot use this correlation coefficient. Later on, if you have extra statistics, you know about chi-square test. Okay, so let's start with any data, any two variable, you can graph the relation between them using scattered plots, right? So using the scattered plot, you may have this shape, right? So it is clear from the left to the right is going up, right? So it means they are increasing together. So the relation here is positive and linear because the graph very close to the line. Next, from the left to the right, you're going down. So it means it is negative because it depends on the slope, right? The slope of this line is positive. The slope of this line, when you go from the left to the right, is going down, so it is negative. But when you have such one, this is like a curve. So this is call it curvilinear relationship. But this is a messy one. You cannot decide it what is the relation between y and x. Okay? That's fine. We know now if I have two variables, x and y, I can make scattered plots for the data, okay, for each pair, x and y, x and y. So I can know the relation. If it is going up from the left to the right, it will be positive. Going down from the left to the right, it is negative relation. If it is like a curve, they call it curvilinear. If it is a messy like this one, you cannot decide if it's curve or a line, so there is no relation. Fine, let's go for this one. Yes, this is a category of companies, right? And this is the cars in 10,000s, the number of cars in 10,000. And this is the revenue of these cars in dollars, in billions, right? I would like to know the relation between the number of cars and the revenue, right? Okay, so if I make the revenue in the y-axis and the number of cars in the x-axis, and I get the first pair 63 and 7, so if I go for 63 and 7, this is a point. The second pair 29 and 3.9, so say 29 is here and 3.9 is here, right? So I represent each pair as a point. So I scatter the points here. It's very close to the line. From left to the right is going up. So the relation between the number of cars and the revenue is positive, right? This is what I said. Let's go for another one. You have a number of absence. How many times this student A absent, and the final grade result. This means the relation between the attendance of the course and the final grade of the course. If I get the points 6 and 82 and the point 2 and 86, etc., I will have this such points scattered. From the left to the right, I'm going down. It means what? It means the more absence, the lower grade. This is what does it mean. So the relation here is not positive. They are not increasing together, right? If the absence increasing, the grade decreasing. So it is a negative relation or inverse relation, they call it. Okay. Now we know from the graph, can we measure this type of relation, positive and negative? We measure it by something called correlation, linear correlation coefficient. This linear correlation coefficient values between -1 and +1. And this is the formula for this one. It depends on x and y and the multiplication of x and y, right? So if these values is 0, it means this one equal to this one. So you have 0 over anything, it will be 0. So there is no relation between x and y. But if you get less than 0 in the negative side, the relation will be negative. What does it mean negative? One increasing and the other one decreasing, and vice versa. But if your correlation coefficient, linear correlation coefficient, greater than 0 to up to +1, it will be positive. It means they are increasing together or decreasing together. Can I determine the values to say it is moderate, weak, moderate, strong? Yes. They agree from 0 to 0.5, it will be weak. Positive relationship if it is positive. Weak negative relationship if it is minus 0.5. But if it is greater than 0.5 up to 0.7, and some boxes write it 0.75, it will be moderate. If it is more than 0.7 or 0.75, it will be strong linear relation, even positive or negative, right? So this is how to judge the strength of the relation between the two variables x and y. Yes, to summarize all of this one, the correlation coefficient is unitless measure. It doesn't depend on the units because you have a fraction and the unit will be cancelled from the numerator and the numerator. And the value of the correlation coefficient between -1 and +1, okay? And if x and y interchange, the value of r will be unchanged. If they are going in the same pattern together, so the correlation coefficient will never be changed, right? Because it depends on the value, okay? Now, the value of r is sensitive to outliers. Do you remember the outliers? Yes. We know how to find the outliers. The lower one will be the minimum minus 1.5 times the interquartile. And the upper bound of the outliers will be the maximum plus 1.5 times the interquartile. So we know these outliers affect the correlation coefficient. Okay, this is the formula. Okay, this is how to calculate it. Don't worry, using the calculator you can do it. Okay, no need to do all of these columns and to substitute in this formula. You can do it by the Excel, and even the normal calculator can do it for you. Once you find the value, this is what I need you to interpret this one. Once it is greater than 0.7, it means it will be strong positive relation. What does it mean, strong positive relation? It means if x is increasing, y also is increasing. Okay? Now, this is the other one, but when we get the correlation coefficient, we get it as a negative. Once we have a negative, we know it is a negative relation or inverse relation. It means one of them increasing, the other one decreasing. If x and y, x increasing, y will be decreasing, and vice versa. And also it is strong because it is less than minus 0.7. This is what the point of having this one. How to find the line, the best line. Okay? Because we will disagree if someone will say this is the best line, this is the best line, this is the best line. To get rid of all of these one, we will have the regression equation or the linear regression equation. Okay? So we are looking for the coefficient A and B. B, they call it the slope. A is they call it the y-intercept, right? This is the y-intercept and this is the slope. How to find the slope? The sun over the rise, right? For any 2 points. Okay? This slope must be agree with the sign of the correlation coefficient. If the slope is negative, the correlation coefficient sign will be negative. And if the slope is positive, the correlation coefficient must be positive sign. Okay, how to find the coefficient A and B? This is the formula of A and B. Okay. Also by the normal calculator, I will show you how to find A and B. Right? B is positive, right? If you get the correlation coefficient, and we'll do it now, we will see also the B. But the slope doesn't give you indication about the strength of the relation. It gives you only the side of the relation, positive or negative. But the strength will be done by the correlation coefficient values. Okay? What is the point of having this equation? I call it the prediction equation because X, they call it the predictor. Okay? Once you put the value of X, you can find the expected value for Y, even if it is not one of your data elements, right? This is why they are using the regression equation to expect any values in the future or before or in between the data you have it. Okay? This is the point. This is the best line for specific data, right? So maybe you have only one point in the line. You maybe have more than one point, but this is the best line up to this calculation, right? So you can extend this line. So you can expect it values for the future, okay? Or you can get the value in between two data here. I don't have this data here, so I can expect it up to the prediction of the regression. Also here, the slope is negative, so the best line will be going down from the left to the right. Also, if I get the correlation coefficient, sorry about that. If I get the correlation coefficient of this data, I will find it is negative, right? Let's go for the exercise before we leave. Shall you open the Excel with me? Now we have two variables, the speed, mile per hour, and the braking distance. The driver should be careful between the front car and the behind one. So this will be 20 feet. Let's go to write these two variables together. This is the speed, mile per hour, and the other variable is the braking distance. Okay. Shall we make this one slightly bigger? Okay. Shall we type the first variable, 20, 30. Okay, if I have a button like this one, 40, 50, is not a button because you jump from 60 to 80, right? Now I'm just writing this one. I'm writing the other variable, the braking distance, 20, 45, 81, 133, 205, 411. Okay, I just make it in the middle. Okay, I'm just giving border. Okay, now I'll go. I finished with the presentation. I'll just make this one bigger. Now I would like to scatter plot this one. So I'm just shading them. I go for insert. I go for scattered. Yes. From this one, I know this is a scattered plot. I would like to have the best line. Okay. So I'll shade it again. Okay. Instead of using the scattered plots, I'm using this one, right? So it will give me this one, get this one, get this one. So it doesn't give me a line, right? Okay. So if you press here and you just go for add, you can make data label. Okay. And the trend line will give you the best line. Once you choose the trend line, it give you the best line, right? Okay? Only one point of your data lying in the best line, right? I would like to have the equation of this one, right? Okay. Where is the equation? How I can find the equation? Yes. Double click in the line. I just have here, I go for the linear. Yes, this is a linear. I would like to tick the equation. Where is it?
Apply equation, doctor.
Where is
On
it?
chart. At the second one.
Second one.
Down, doctor.
Okay, okay, with you.
The second tick.
This one.
Yeah.
Yes, excellent. So now I have the best line. This is the regression equation. Okay, just make it slightly bigger. Okay, so I just change this one and I'm writing regression. I have to write it linear regression, linear regression equation. Okay, for speed and the braking distance. Fine. Okay, finish. Thank you. That's it. So if I am asking you to find what is the braking distance, if I'm just saying your speed was 55. 55 is not one of your data, so you can go for 55 here, go up, right? And then horizontally to know the speed, right? This is how to use the regression equation. Also, if I give you the braking distance, okay, say I gave it to you 150. 150 is not one of your braking distance, right? So I'll go for this one. So it is better to give a title for the axis, right? So go here and make axis title. Just to know this is what? This is a mile per hour or the speed. Yes, this is a speed. And this is what? Sorry, I'm just making the opposite side. The opposite side, yes, sorry. This is the braking distance. And this is the speed, mile per hour, right? So now I have this one. Once I know one of them, I can get the other one. So if you give me the braking distance 150, so I will go for 150 here, which is exactly here, and go horizontally until I intersect the line, and then go down here to know the speed. This is the point of using the regression equation to guess this one. If you would like to have the correlation coefficient, okay, what is the function for the correlation coefficient? There is a function, okay, there is a function, okay. This function, once you shade these two, right, and go for the function, right, this is the name of this one, correlation. So you just type correlation. You just type this one. It doesn't give me the correlation. Oh, okay. Yes, because it's not in statistics. So I have to go for statistics. Where is the statistics here? Okay. So I'll choose, if I go for statistics, I know correlation is sorted by alphabetic. So I know correlation is C. So I'll go for the C. I have count. This is a correlation. Yes, here it is. This is a correlation function. So I press OK. I just shading. Okay. I shade this, both of them. Okay. Press OK. What's wrong here? What's wrong here?
دكتور كان طالع لك مكانين تعمل منهم شيد ف you should shade
Yes.
the x-axis first then the y-axis.
Yes, this is the point here. Yes, this is the point. I'll go again for the function equal. Press, sorry, press here, press equal. I go for the function. The correlation is already, I use it, right? So if I go for the recent, I have the correlation. Okay, no need to look at it again. Correlation. Look at this one. You have two array, right? One for the x-axis and one for the y-axis. Okay, is it? Let's go for the first one. Y. Okay, I'll go for the breaking distance. Okay. Now I'll go for this one. I delete the M and it will not write for me anything here. So I will leave it blank here. Okay, and let's see. Press OK. Now he gave me the correlation coefficient, right? Once it is greater than 0.75 to be in the safe side. Some boxes write it 0.7. So it is a strong positive relation. A strong positive relation. The main point I would like to check here is a positive. The slope here also is positive, right? But the slope gives you the indication of the relation, but doesn't give you the strength like the linear correlation coefficient. Okay? This is the point. So the slope sign agree with the sign for the correlation coefficient.